Automatic, Addison.
In this tutorial, I'll show you how to use Pytest to write and run unit tests. Imagine you're building a complex robot using ROS2. Your robot is made up of many different parts, each controlled by a piece of software. Now, how do you make sure all these pieces work correctly? That's where unit testing comes in. Unit testing is like doing a health checkup for each part of your robot software. It is a way to automatically test small pieces of code to make sure they're doing exactly what they're supposed to do. Unit tests are essential tools in robotic software development for two key reasons. First, early bug detection. You can automate the testing of code to ensure that changes or updates don't introduce bugs. Number two, improved code design. Writing testable code leads to cleaner, more modular software. And in this test, I will show you a tool called Pytest, and we'll use it to write tests for individual parts of your code, such as functions and classes, to make sure each part behaves as expected. Now, Pytest is designed primarily for Python code, so it's commonly used for testing Python-based ROS2 packages. For C++ code in ROS2, other testing frameworks like Gtest are typically used instead. Let's write a basic unit test for the ROS2 publisher node we created in a previous tutorial. This test will verify three key things. One, that our node is created correctly. Two, that its message counter works properly. Three, that it formats messages as expected. We'll create a Python test file that uses Pytest to run these checks automatically. Open a terminal window. Let's move to the workspace. Let's move to the package. And we're in the ROS2 fundamentals example package. And let's create a new folder, make dir test. Actually, let's do the -p and then /Pytest to create the folders. All right. And let's go check it out here. Okay, we got test in there. Let's go inside here. And we got Pytest. So we created two folders, test folder, and then a Pytest folder that's inside the test folder. Okay, and let's just go back here to the package. Let's open Visual Studio Code. And you can see, okay, first we have to type our password. Okay, and let's go to test, Pytest. Right-click on that, and let's create a new file called testpublisher.py. And let's write our test suite for our ROS2 minimal Python publisher node. Start out with the shebang line, usr bin inf python 3, and let's definitely get a header right here so you know what's going on. Okay, and let's say test suite for the ROS2 minimal publisher node. And we're going to say this script contains unit tests for verifying the functionality of a minimal ROS2 publisher. Okay, and what else does it do? It tests the node creation, message counter increment, and message content formatting. Okay, let's put our little divider here, and let's say subscription topics, none. publishing topics. Okay, let's go over here. Okay, and we just want to keep track of the Py example topic, which is a std message string. Okay, and I'm going to say example messages with incrementing counter. Author, Addison, Sears, Collins, and the date, which today is April 12th, 2025. Okay, close out that header. Now let's create our method. So def test publisher creation. And let's do test if the publisher, oops, let's actually write a comment here. Get rid of this summary. Okay, and let's just write a comment to test if the publisher node is created correctly. We just want to test if the publisher node is created correctly. And so this test verifies, one, the node name is set correctly. Two, the publisher object exists. And then three, the topic name is correct. Okay. And if that stuff isn't correct, we want to raise an error. So raises assertion error if any of the checks fail. Okay, so that's our method. Now, very key. To do Pytest, we need to add some imports up here. So I'm going to say import Pytest. Import RCLPY for the ROS2 Python library. We're handling string messages or working with string messages. So from std messages.msg import string. And then from ROS2 fundamentals examples.py minimal publisher import the class we created earlier, minimal Py publisher. Okay. And now in this method, we need to first initialize ROS2 communication. How do we do that? We do rclpy.init. Now let's do a try finally block. And the first piece in here, we're going to create an instance of our publisher node. And we're going to say node equals minimal Py publisher. Okay, now we do test one, which is verify. We need to first verify the node has the expected name. So verify the node has the expected name. Okay, and how do we do that? We assert, and then we do node.get underscore name equals, and we do minimal Py publisher. Okay. And let's do our test 2. Test 2. We do verify the publisher exists and has the correct topic name. Okay, and to do that, we do assert has attribute, and we do node, comma, and then publisher underscore 1. Now we do assert node.publisher underscore 1 dot topic underscore name equals py example topic. Okay, and then finally block. And let's do clean up ROS2 communication. RCLPY.shutdown. Okay. So that's testing the publisher creation. Okay, let's do def test message counter for our next one. And this is going to test if the message counter that we have in that Hello World publishing increments the message counter correctly. So we're going to say test if the message counter increments correctly. Okay, this test verifies that the counter, which is node.i, increases by 1 after each timer callback execution. Say raises assertion error if the counter doesn't increment properly. RCLPY.init to begin ROS2 communication. Let's do our try block, and we'll do node equal to minimal publisher, PyPublisher. And let's do initial count equal node.i. Let's do node.timer underscore callback. And we'll do assert node.i equals initial count plus 1. Okay. Create the node. Create the initial count variable. Run the callback. And then we want to assert that that counter is continually increasing. Let's go over here, finally, and let's do rclpy.shutdown when we're done. Now let's do def test message content. Let's do our comments again. And let's say test if the message content is formatted correctly. Okay, and what does this test do? This test verifies that the message string is properly formatted using an F string with the current counter value. Make sure everything is formatted correctly. If it's not, we want to raise an assertion error if the message format doesn't match the expected output. Okay. Just like we did in the previous, we need to, let's bring this over so you can see everything. Okay, let's do rclpy.init. Let's do try. Let's do node equals minimal publisher.py, minimal py publisher again. Okay, and let's set counter to a known value for testing. Node.i equals 5, message equals string. Okay, and let's go down here using f string instead of the % formatting. Okay, message.data equal to f hello world node.i. Okay, and then assert message.data equal hello world 5. Finally, and then rclpy dot shutdown. Okay, and let's do our typical if name equals main, and then Pytest. This is where we do Pytest main. Okay, and we do open parentheses, square bracket, quote, -v, and then save. Okay, let's go back over our code to make sure we don't have any red squigglies, which will prevent our code from running. So let's see. So here in this first method, we're testing the node creation, that the publisher node's created correctly. And I see node is not defined. Okay, so there's the problem right there. Put an equal sign. Okay, and save. All right, that's okay. This tests if the publisher exists with the appropriate topic name. Here we're testing that the message counter increment on those hello world messages is incremented correctly. And here we are testing the formatting of the message to make sure the formatting is correct. Those are our 3 tests that we're running. And we are going to evoke the test using pytest.main. Okay, and then save. Pytest.main. So I made this check as well. Everything looks pretty good so far. Everything all green. All right, and as we usually do when we create a new script like that, we need to go to let's close that out. Need to go to CMakeLists.txt. And here is where we go to get down into the if build testing you're probably wondering about. What are we going to do in here? Well, down here, we need to put some stuff in here for Pytest. So we have this block right here. Let's just comment out this first line. All right, and then we need to do, since we're using Pytest, we need to do find underscore package, ament underscore CMake underscore Pytest. And they're going to do required. Okay, ament CMake Pytest required. This set ament CMake found true. We can comment that out. We don't need it right now. This ament CMake CPP lint found true. Let's comment that out. We don't need it. Okay. We don't need these test dependency piece either. Okay, and then down here, let's do ament add Pytest test and do minimal Minimal publisher test. Okay, minimal publisher test, and we're going to do test. Where is it? It's in test, Pytest, test underscore publisher dot py. Okay. Move the parentheses down. And let's give a timeout for the test. I'm going to say timeout 60 seconds and then save. And then our end if. Okay, so that's good. We're now using this immense CMake Pytest. Let's go over here to our package.xml. We need to make sure that our tests are discoverable to CMake. So in the test depend, we need to add this here. And we need to do a mint CMake Pytest. And then save. Let's just double check on that. Looking good. Okay. Save. So that's editing our package.xml file. Now let's go over to our terminal. Get a fresh terminal open. Let's go to the root. Okay, let's go to our workspace, cd ROS2 workspace, and type this command. We want to make sure we install all the dependencies that this needs to run. So ROS-dep install -- from paths src and then -- and then ignore src space -r-y. You run this command in the workspace. You're going to run it a lot over the course of your robotics career. And what this is we're going to scan the package.xml file, make sure we've got our dependencies installed that we need to actually build and run our code. And if anything is not installed, it'll prompt you to install. So run that now. And all required ROS-deps are installed. Now let's just build this package, -build. And let's do packages, -- packages, select, and then ROS2 underscore fundamentals examples. And everything built. Now let's source the bash. Okay, now that we have built everything, we now need to run our tests. Let's start by doing that. Going to the workspace, let's do tests, and then packages, select, packages, -select, and then ROS2 underscore fundamentals examples. Okay, we've got some failure. It's got some failure. Let's go back to our code and let's see what the issue could be. Just walk through. PyExample topic. Failed pretty quickly too. Where is the issue? Oh, okay. Let's try that. Topic name /. Okay, remember ROS2 topic names have a /. So let's save. Let's go back here and let's build again. Let's do a :build. Let's just do a build. Okay, let's source bash rc and let's run the test again. Everything worked beautifully. Tests work just as we expected. So you can see how these tests come in handy. You can check errors and other things, and it's very good to do this unit testing as part of your workflow. And to get more detail, we could have run another command, another colcon test command. Let's do colcon test, and then let's do -- packages select, and then ROS2 fundamentals examples, and then space, and then -- and event handlers, and then console_direct. You don't need to know what all this means. Essentially what this does is it just gives you more detail to the unit test that you're performing. So it's colcon test space -- packages select, all right? And then the name of the package, which in our case is ROS2 fundamentals examples, and then space, and then -- and an event handlers, and then space, and then console_direct, and then the plus sign. So you can see 100% test fast, 100% test pass, and then 0 test failed out of 1. All right. And you've got a lot of other gobbledygook that comes out. And you notice that when we run our unit test with this command above, you first start by loading the ROS2 package. The system then collects and runs our 3 test cases. You know, in this case, and that's what's going on all in that gobbledygook right here. And just scrolling down. Okay. And you can see the 3 test cases. So it said 3 passed in 0.33 seconds. So that indicates that all is good. So, and these 3 dots right here represent the successful runs of our 3 tests, which are the publisher node creation, the message counter, and the message content. So you should see this 3 passed in whatever seconds, might be different on your machine. And then the final summary right here, we see 0 tests failed out of 1, 1 out of 1 passed with flying colors. So my final summary right here, it shows that our single test suite, which was this minimal publisher test, passed successfully in 0.93 seconds. Okay, reporting a no failures, which is exactly what we wanted. Now, once that's finished, let's clear the terminal and let's check the results. So let's do colcon test -result, and then space, and then -- all. And those show the tests right here. All the results. And then to see any test cases which failed, you would do colcon test -result space -- all, and then -- verbose. And that would show you anything, you know, that failed, any test cases that failed. So that is it for Pytest. That's the fundamental basics, the basics of Pytest, which is a very powerful tool to test different small pieces of your code. Thank you for watching, and keep building.